All right, here we go. Question number 31. We're told to consider the quadratic function f of x equals 2x squared plus 20x plus 47, and we need to write f of x in vertex form. Vertex form means that we want to write this as a times x minus h squared plus k. That's vertex form. Now, how we're going to go about doing this is a technique known as completing the square. What we're going to do is we're going to focus on these two terms right here. I'm going to factor out the 2, which leaves me x squared plus 10x. The 47 is left outside of the parentheses. My goal is to figure out what value to add to this part inside the parentheses to make x squared plus 10x plus that value a perfect square trinomial. To do that, we're going to take the positive 10, divide it by 2, and square it. You're going to get 25. You're going to add in 25. But now here's the thing. You should know better than this. You're in Algebra 2. You can't just add 25 to an equation without losing the balance. Even worse, that 25 is being multiplied by 2, so what you really did is you added 50 onto the right side of the equation. To maintain your balance, you could add 50 on this side, but we're not going to do that. Instead, we're going to subtract 50. And the end result is that this side of the equation is still balanced. It just looks different. We have 2 times x squared plus 10x plus 25 minus 3. X squared plus 10x plus 25 is the same as x plus 5 times x plus 5. So finally, f of x is 2 times x plus 5 squared minus 3. That's the vertex form. We offered 1 point for getting the x plus 5 squared part, and then another point if everything was correct, meaning you had the right constant there, for a grand total of 2 points. That was part A. Part B, now that you know that you're in vertex form, well, the vertex is always h comma k. In this form, ax minus h, that means h is negative 5, plus k, that means that k is negative 3. That's your vertex. This was worth just 1 point. Finally, in part C, what are the roots of f of x? This is the same as asking where is f of x equal to 0. So if f of x is equal to 0, you've got a choice. I'm going to say option 1 involves taking my original equation, the 2x squared plus 20x plus 47, setting that equal to 0. That is a quadratic equation, set equal to 0. You could try to factor this if you want to. I can tell you it's not going to factor. What I would recommend is that you use the quadratic formula. You've been working with the quadratic formula since Algebra 1. X equals negative b plus or minus the square root of b squared minus 4ac, all over 2a. For this problem, a is 2, b is 20, and c is 47. You'll just plug all of those things into the quadratic formula. You'll simplify, and we're good from there. Option 2, well, let's go here, and I might need a little bit more space. I've already done this work to write f of x as 2 times x plus 5 squared minus 3, and I want to set that equal to 0. What I'm a big fan of doing is using inverse operations to get the x by itself. What did I just say? I'm going to add 3 to both sides. 2 times x plus 5 squared equals 3. I'm going to divide both sides by 2. X plus 5 squared equals 3 halves. I'm going to take the square root of both sides. Now, when you take the square root, you do have to consider both the positive and the negative version. So I'm going to say that this is the same as, let me write it up here, x plus 5 equals plus or minus the square root of 3 over the square root of 2. I can rationalize the denominator by multiplying by square root of 2 over square root of 2. You get x plus 5 equals plus or minus square root of 3 times square root of 2 is square root of 6. Square root of 2 times square root of 2 is the square root of 4, which is 2. If I subtract 5 from both sides, you get x equals negative 5 plus or minus the square root of 6 over 10. That's a great answer. If you want to get a common denominator between your two fractions, your final answer will be negative 10 plus or minus the square root of 6 over 2. We awarded 2 points, and yeah, it's kind of, I'm not going to bother telling you how we broke this up, but getting to this final answer was worth 2 points. If you had used the quadratic formula, you would have done different steps, but you would have ultimately ended at the same answer. Not bad. That's the end of that question.